Now, the next few questions that I will be looking at are going to start going up in level of difficulty and, of course, the grades. Because there will be a lot more thinking behind it. There may be more applications of the different theorems. So pay attention. Make sure that you're writing down the notes. Maybe make a copy of these diagrams in your books and write down the reasons as I say them as well, because the reasons carry the marks. Right, so having a look at this next question here, it says it wants us to work out angle BAD. So let's mark that in here right there. We know that this is the center of a circle because we've got that O for origin. Right, we are given this as 130. Now, one thing I want to just highlight to you is you have this quadrilateral here. This is not a cyclic quadrilateral. Do you know why? Hopefully you remember that a cyclic quadrilateral has to, all the vertices, all the corners of the quadrilateral have to touch the edge of the circle or the circumference of the circle. So this is not a cyclic quadrilateral. It is just a quadrilateral. However, if you look at the bigger one here, that is a cyclic quadrilateral. So, which means that this angle here and this angle here, they both add up to 180 degrees. So, straight away, we can find this angle here. So we can say 180 minus the 130, and that gives us 50 degrees, and we have our angle. Now, you may be wondering, hold on a minute, you just told us that we're going to start doing the harder questions, and this was over in one line. That's because there is a part B to this question, which I couldn't display on the board, and I've written it down here, which is to find the angle ODC. So, where is angle ODC? So, ODC, we need to find this angle right there. And that is going to present a lot more of a challenge for us. Right, so let's see where we left off from. We had this as 50 degrees, so therefore, what would this angle be? This angle would be double this angle because, if you notice, these two lines and these two lines at the center, they come from that same point, the same arc, okay? So therefore, this will be twice 50. So therefore, that will be 100 degrees. Now, if you recall, we have this smaller quadrilateral right here. So therefore, these angles here, they all add up to 360 as well. However, what type of shape is this? What kind of specific quadrilateral is this? As you know, quadrilaterals have many types. You have squares, you have rectangles, you have trapeziums, and all sorts, okay? What kind of quadrilateral is this? The clue here is these markings here. These markings indicate that this length here and this length here are the same. Also, since this is the center of the circle, this is a radius and this is a radius because they go to the circumference. So therefore, these two are the same. And therefore, we have a kite. And that means that these two angles right here, they are exactly the same. So therefore, if we add those two and then take it away from 360, we can divide it by 2 and distribute whatever's remaining between these angles, which are the same. So let's do that now. So we're going to do 100 plus 130 gives us 230. We're going to do 360, take away 230, which gives us 130. And then we are going to do 130. We're going to divide this by 2. We could divide by 2 because they are the same. They will take the remaining, or they will distribute amongst themselves the remaining angles. So 130 divided by 2 equals 65 degrees. So therefore, ODC is 65. And this is also 65, which we are not asked for. We just asked to mention, the angle here is 65, and that's it. As always, remember to give the reasons. Working out alone may not be enough to get you your marks. Make sure you give your reasons for every step of the way. So here where we had angle at the center is twice the angle at the circumference. We had the cyclic quadrilateral, so therefore these two angles adding up to 180, so on and so forth. And also about the kite. Oh, these two angles are the same. Make sure that you supply all your reasons to the examiner. Don't give them an excuse to mark you down in any way. Right, on to this next question here. You may not be able to see this, so I will read it to you once, or you can take you can pause the video and write down the information by zooming in if you can. But then I will zoom into the picture more clearly, the diagram, and then you can see everything in more detail. We are given this circle with the various markings, and we are told to find the angle ABD. Perhaps you want to try this one yourselves and then press play again when you're ready to go through it. All right, so let's have a look at this one. Finding angle ABD. So let's make a marking of that. ABD is this angle right here. Okay, we have this diameter here. So diameter from there to there, but radius from there to there. We have a tangent to the circle. We are told that this is a tangent to the circle from the information in the question. So that means that this entire angle here, although we are given this 35, this angle here is 90 degrees. So if we want to find what this angle right here is, we do 90, take away the 35 that we are given. So 90 minus 35, which gives us 55 degrees. Now, part 2 to this question is to find angle DEB. So let's go and make a marking of DEB. So DEB. So that is this angle right here. So which rule do we apply here? If you notice, we have a tangent here, we have a chord, and this is one segment. So therefore, this will become another segment, and we can apply the alternate segment theorem. So therefore, this angle here and this angle here are going to be the same. So if this is 55 degrees, which we found out earlier, this is also going to be 55 degrees as well. And the reasons, please make sure you give your reasons. The first one was angle between a tangent and a radius is 90 degrees. That should be enough. And the second one is the alternate segment theorem. All right, let's have a look at this next one now. We have a very complex diagram. So as you can see, the questions are starting to get a lot more complex now, and therefore the grades are going to be higher for it as well. So we have P, Q, T are 3 points on the circumference of a circle with the center O. And we are told that the line ATB is a tangent to the circle, and we are also told that PQ and TQ are equal. Okay, and we are given this angle of 58 degrees here. Calculate the angle of OTQ. So let's mark OTQ. So where's that? OTQ. So we are finding this little angle right there, OTQ. So where do we begin? Right. I can already spot that we have an alternate segment theorem here. So the tangent here with the chord, the angle that it makes, is going to be the same as when the same chord has 2 points or 2 lines coming away and meeting at the circumference in the alternate segment. So therefore, this will be 58 degrees. Now, I have this triangle where I've been told that these two lengths are the same, making me have an isosceles triangle. And as we know, with an isosceles triangle, these two angles at the bottom here are the same. So if this is 58, so we can do 58, take away from 180, and that gives us 122 degrees, and we can divide the 122 degrees by 2 because we have our isosceles triangle, and that gives us 61 degrees. So these two angles here are 61 degrees, giving this 61 degrees here, and also this 61 degrees there. Now you can do this next part in two ways. You can either look at the straight line here and the angles on the straight line and work from there, or you will notice that you also have on the other side another alternate segment theorem, because you have a chord right there and it makes an angle with the tangent, and in the alternate segment you have another angle here. So this is 61, which we know already, so therefore this is also 61 degrees. The final part, because this is still not worked out the angle that we need, which is OTQ, the final part is this we know is a radius, and this is a tangent, so therefore the angle that they make between themselves is 90 degrees. So in order, and I want you to pay attention to this now, in order to find our little angle of OTQ, we take away the 61 degrees from the full 90, because this is 90 degrees. Okay, so we are going to do 90 minus 61, and that gives us 29 degrees. So our angle OTQ is 29 degrees. Once again, I cannot emphasize to you how many times I have seen students losing marks because they do not give reasons for each stage of their working. So make sure you mention that you've got an isosceles triangle. Make sure you mention that there's an alternate segment theorem. Make sure that you mention that the angle between a radius and a tangent is 90 degrees. On to our final question. Hopefully you're still there, you're still around, you haven't switched away yet. This would be a good question for you to do at home because you can apply all the techniques that you've learned and give the different reasons. So press pause here and press play again when you're ready to go through it. Okay, so let's have a look at this question. We are told to find angle X here. We are given this angle as 32 outside of the circle. So where do we begin? We know that we have a tangent right there. We have a radius here, so therefore we know that this is 90 degrees right there. If we know that this is 90 degrees, then this triangle that we have here, we can find that third angle right there. And in order to find this third angle, we'll add up these two, so 90 plus 32, which gives us 122 degrees. And this one will be 180 minus 122, which gives us 58 degrees. So we have this angle here, which is 58 degrees now. How do we find X here? Now let's change the color here. So what do we know about this triangle here? We have a radius here, we have a radius here. So therefore, these two sides are the same. What kind of triangle do we have then? We have an isosceles triangle. Remember to write these reasons down as you go along as well. So if this is an isosceles triangle, this angle here and this angle here will be equal. So if we can find this angle, which we can because angles in a straight line, add up to 180. Once we find what this angle is, we can distribute the remainder between these two angles, and there we have our X. So let's go do this now. So start off by finding this angle here, which will be 180 minus the 58. That gives us 122 again, just like this one earlier, but it's independent anyway. And then we do 122 take away from 180 because the angles in a triangle add up to 180. So 180 take away 122. That gives us 58 again. It seems like you're going back and forth, but you're doing certain things for specific reasons. And this is important because you're giving the examiner at each step of your working reasons for what you're doing. And this is why they ask you for the reasons. So you actually make it clear you know what you are doing. So we have 58 and we will distribute the 58 between these two because these two are isosceles angles or angles of an isosceles triangle. So therefore 58 divided by 2, which gives us 29 degrees. And therefore this is 29 degrees and our X is also 29 degrees. So there we have it, X is equal to 29 degrees. Hopefully you've enjoyed this lesson. Please copy down the theorems onto small cards so you can have a look at them whenever, every now and then. And most importantly, go and practice some questions. Go on the internet, do a Google search, find some worksheets on circle theorems and apply what you've learned. See you in the next video and thank you for watching.